Welcome back to Get XAML. We'll start with the second chapter, Introduction to Statistics. So in this chapter, basically, we're going to understand what statistics means. Okay, there are some terminologies like population, sample, and then we'll understand the motivation why I'm studying this. Whatever chapters you are henceforth studying from chapter 3, that is probability theory, chapter 4, random variables, chapter 5, mean variance of random variables, then some discrete probability distribution, some continuous probability distribution, and the central limit theorem, confidence intervals. All these things you are going to learn as part of your syllabus. So this is the motivation, like why I'm learning this. Okay. So let's start with introduction to statistics. You'll see some terminologies like what is probability, what you mean by statistics, okay, what you mean by population, what is a sample. So entirely I'm going to give a picture like what is that you will be learning and why you will be learning it. Okay, so that should be clear before you start studying any concept. So when I teach some concept, you should be able to correlate. Okay, why I'm studying this, what is the importance of that topic. Let's begin. First, what is probability? Okay, so technical definition I will introduce in chapter 3, the probability theory. Now let us understand what in general what you mean by probability, why we need it. Probability is a branch of mathematics that deals with measuring the likelihood of events happening. Okay. So basically it starts with a known model or a process. Basically you call it as a process. See, any process in this real world generates some data, right? So that, for example, say that there is an experiment or a process I'm conducting, that is tossing a coin. So let us say we are playing a game, tossing a coin. So that is a process. So it generates certain outcomes, certain data. Okay, a very simple example. So example maybe rolling a die. So it produces 1, 2, 3, 4, 5, 6 faces, right? Similarly, tossing a coin, it produces heads or tails. So then what it answers, given a known situation, what outcomes are likely and how likely. So what are the outcomes for tossing a coin? We know it is heads or tails. Right? So two outcomes are likely. And how likely? The probability of getting a head is 0.5. That is, since there are two outcomes, head and tail. So one is head. So half. That is how the probability helps us. So it basically gives us what are the possible outcomes and what is the likelihood of that outcome. Okay. Now we'll come to statistics. What is statistics? Statistics is a science of collecting, analyzing, interpreting, and making decisions based on data. Basically starts with sample data. Don't worry about what you mean by sample data. I'll explain in the next slide. And tries to learn about the underlying population. So given some sample data, from that to learn some or make some observation. Based on that observation, we will make a decision. See, the entire world, like whatever applications you have currently, works like this. For example, if you are watching a YouTube video, so and your friend is also watching the same video, do you think they will get the same advertisements? No, right? Because whatever data, so whatever you are interested in, you may be interested in soccer or football. He is interested in cricket, right? So the data is different, so their learning is also different. So the data collected from your observations forms a different analyzing, interpreting, and making the decision for the system. That is what it means. So for example, so what it does, based on what I observe, what can I say about the larger group? Okay, let us take this example. A survey of 500 voters shows that 60% favor a particular party. What does this say all about voters? Okay, see, there are crores of voters voting. For example, say there is an election in India. So there are crores of voters voting. So you observe the TVs before the election results are announced, there is something called as exit poll. The news channels will give something called as exit polls. So they predict like which party will get how many seats, who will win. So how they will do it? You mean to say that all the crores people, whatever, they will take the samples from them or they will take the results? No. When the counting is done, all the crores votes will be counted. But how these people, news channels will predict, okay, a near outcome, okay. I'm not saying the exact result, but something they will predict. How they do it? They will not collect all the crore samples, right? They will not go and ask everyone who what you voted for. They may not get the answer also. So what they will do? They basically take some sample, that is called as sample. Sample means what? Some people they will conduct a survey and ask them in a particular state to whom, which party you have voted. Based on that sample, they make a inference. Okay? These are some terminology to understand. So this entire crores, whatever people have voted, is called as population. Entire population. Sample, inference. Okay. Now let us try to understand in depth what is population. The population means, you can visualize like this, the entire universe. Okay. Entire data. Okay. Now let us take an example. I want get average salary of employees in India. What I am saying is I want to estimate or get the average salary of employees in India. Let us say there are 10 crore employees in India. So this becomes my population. All employees working in India, say let's 10 crore is the population. So this entire universe of this data set is the population. Now, so how to find the average salary? So one method is what? You get the information data of all the people, all the 10 crore people, and take a average about it of the data. So is it really possible? There are many things here. It may not be feasible, it may not be practically possible. You may not be able to process all 10 crores employees data, right? So for that, what we'll do? So to avoid that, we'll say collect some sample. Sample means smaller size. So based on my requirements, okay, what is that I'm doing? I will collect some samples. Say I'll collect a sample of say 50,000 employees. This 50,000 is coming from what? The population. See, this is the entire population. From that, I'm taking 50,000 as a sample. So 50,000 data points, 50,000 employees data as sample. And then I will apply the average. You can easily calculate now. Average and say I'll get some average value. Say rupees 30,000 is my average value. Okay, 30K is my average value. So average employee salary is 30K. But this 30K is calculated for what? For the sample, right? Is calculated for the sample. Now, how good is this for the entire population is the question. Okay, let us say what I calculated is X bar. X bar is equal to 30,000. Let us say mu represents the entire population average salary. Now, how good is this? Is mu is equal to X bar? Can we say that? No. We will add some plus or minus error, some error. Okay. So this is all about statistics that you are going to learn. What we are going to do first, we have an entire population for study. Then we'll take a sample out of it. Then we'll calculate say some characteristics. Okay. In this example, I've taken mean. It can be anything. Okay. Your character of your interest. It can be median. It can be anything. And then we'll say we'll calculate that value using sample. This is sample mean. This is population mean. Okay, population mean or average. So now what exactly it means? See, I am not sure whether it's equal to or not. There should be some error plus or minus some value. Okay. The entire statistics is about finding this and then saying how good is your measure, your average value, that is. How good is your average in this example? That is all about statistics. So this is the inference you are making. Okay, this is the inference you are making. This is the population for the population. So basically you are taking a sample from the population and calculating some values, and then from those values you are deciding the characteristics of the population. So whatever I take a sample, I calculate some values and then I say that this is a good fit for the population. I need not calculate for entire population. I can estimate for the population with certain probability. So that is where you will apply confidence interval, central limit theorem and all those things to see how good is your measure. That is why you are studying this statistics. Okay. So this is the whole picture you should have when you learn any new concepts. Now let us go in deep. So how do they work together? Statistics is one area and probability theory is another area. How they help to make inferences about the population. So you can just imagine like this. What is the aspect? So the probability starts with known population, and then what it aims to find? It aims to find likelihood of outcomes. Okay. Known population means I have process. Okay, from say tossing a coin, that is my, I will get heads or tails, that is the population. So it aims to find the likelihood of the outcomes. Whether I will get, what is the probability of getting a head or probability of getting a tail, something like that. So it basically characterizes the data. Then direction, it starts from population and then it goes to the data, a sample. Now statistical inference, it starts with sample data, because the previous explanation I gave you, on the sample data you apply the statistical inference. Then what you aims to find? You aim to find the mu value, right? Is the population parameter, population value. You are trying to estimate that using your sample data. So it starts from data, that is sample data, and then try to infer something about the population. So from subset you are inferring the superset. That is what it means. So what inference is probability to estimate how likely an observation result is. Now, what is the relation between this? Again, I have explained this. Probability starts with known and predicts data outcomes. Statistics starts with observed data and infers about the unknown, because population value is unknown. Together, they enable evidence-based decision under uncertainty. Next, there are many real-world examples. For example, business forecasting. You have invested in the share market, something like that. The goal is what? To predict future sales. Now you will use the historical data, previous data, to build a predictive model. So you apply some probability theory and then you find a predictive model. Then you make a statistical inference. So similarly legal evidence, quality control, anywhere you go in this world, there are many processes or applications. So basically what I explained now, I summarized here. What is the core concept in statistics? We are often interested in studying a large group of individuals or items called as population. The population is a large group, the universe. However, it's usually impractical or impossible to collect data on every member of the population. That's why I give the example. For the population, entire population, I cannot get the data, entire data, due to many other reasons. Instead, we select a sample, that is a smaller, manageable subset, and use the information gathered from this sample to make inferences about the entire population. That is what the fundamental or core concept of statistics is. So basically, if you want to remember or imagine pictorially, you can just see this population is this entire thing. Then I will take a sample out of the population. This is my sample. Then I'll do some statistical inference. Then estimate the parameters. This parameters applies for the entire population. So that where you learn about hypothesis testing, confidence intervals, etc. Now, the basic question, why do you need a sample? So from entire population, why should I take a sample? The first thing is it is cost effective. It's cheaper to collect data from a sample than whole population, right? So if there are 10 crore people, it's very difficult. If I ask you to only take a sample of 50,000 people, it becomes cost effective. Then it is also time saving because sampling is smaller in size. Takes less time than a full population study. Practicality. Often the entire population isn't accessible. See, if I ask you to get 10 crore employees data, it's not accessible. You cannot get all 10 crores because of many reasons, for privacy reasons. Feasibility. Data analysis become manageable. See, if you have 10 crore data points, it's very difficult to manage the data. But if you have 3,000 data points, it's very easy to manage and then it becomes very fast process. So what is this inference flow? How you infer? Right? First you define the population. Define the population means what is that area you are working. For example, are you finding the employees average salary, or are you predicting which party will win this election, something like that. Find a variable of interest. Example, what is that you are trying to find? So that is, for example, average or median or whatever it may be. In the next video, I'll explain what are these characteristics. And select a representative sample from the population. So first you define a population. Okay, and this is first step. Then your second step is find the sample. Now collect the data. So this is the sample. Collect the data for this sample. Then for this sample, compute something like mean, median, or whatever you want. Okay. Use probability theory, okay, or probability distributions to estimate the population mean. That is, I'm trying to find this value. This is for population, entire population. This is how the inference flow works. Okay, so finally, to conclude, what is probability? Probability is used to model uncertainty in the data generation process. Statistics uses the collected data from a sample to estimate the underlying probabilities and infer characteristics of the population. Simple example, a, a company or a medical company wants to test the effectiveness of a new drug. Instead of testing on all the patients with a disease, they select a random sample of 500 patients. See, they have created a new medicine. Okay, so if a person is suffering from that particular disease for which they have created the medicine, say that there are lakhs of people. So I cannot go and test on all the lakhs of people, right? That is not feasible. That is not practical also. So I will select some 500 patients. That is the sample out of 1 lakh patients. I'll select 500. Then apply the drug on them and collect the data from them, recovery data, how it works. Then use a statistical inference and say that how this drug will work on entire 1 lakh people, 1 lakh patients. So that is the inference I make. Hope you understood this. Next. So what is sampling? You already seen it. Sampling is a process of selecting a subset sample from a large group population to gather insights and make inferences about the entire population. So basically what is sampling? This statistics you are doing here. Inference means what? You take a sample from entire population, you work on this sample, you determine some values or parameters, and then say these parameters for this sample will also be applied to this population, okay, with certain errors. So now what are the steps in sampling? First, you already seen it. Define the target population. What is that you are studying? Okay, interested in studying. Example, all college students in India. I want some information about all the college students. Then specify the sampling frame. This is a list or mechanism that gives access to the population. See, if I want, all the data may not be available. So you create a frame of sample. Okay, this is where I have to collect the sample. Then choose a sampling method. We'll see about this next. There are different sampling methods. How to choose the sample from the population. Then determine the sample size. What should be the size? 500, 5,000, whatever it may be. So based on your need, based on your accuracy, what you want. What are the sampling methods? There are different sampling methods. Okay, the first one is simple random sampling. So let us say this is the population. This is the entire population. Now I want to get a sample. What are different sampling methods available? First one is random sampling. Random means there is a data points here. No, you just pick randomly. So each individual, if you pick randomly, has an equal chance. So randomly I'll pick. That is random sampling. Then something you have called as stratified sampling. Divide into strata, or they are called as groups, and sample from each. So let us say I'll create some groups for this entire population. So these are the groups. Now what they say is, so from this group one you take, from this group you one. So this is becomes sample from each group is stratified sampling. Then systematic sampling. Every kth member is selected. So say member number 3, data point 3 here in this group, data point 3 here, data point 3 here, data point 3 here. So all these kth member will be selected. That is called a systematic sampling. From all the groups I am selecting the some particular member, a particular data point. Now clustered sampling. Randomly select an entire group. So out of these groups, randomly I will choose this entire group as a sample. That is clustered sampling. So based on the data you have, based on the study you are conducting, based on the experiments you have conducted, you will be using these methods. So to pictorially to represent what you do, how you collect the data. So from the population, you will find a sampling frame, and then you will sample, and then you conduct the surveys or experiments to collect the data. So that's about the motivation and basics to statistics. In the next chapter, we'll see about the measures of locations and measures of variability, that is mean, median, variance and standard deviation. So that will be a very important topic to begin with. So please subscribe, like and share with your friends. We'll see you in the next video.